Welcome to C++ with Miyoshi. Today we're going to talk a little bit about character arrays, just a little bit of introduction, and how to output them, input them, and what they are. So character arrays are, as the name implies, characters, and they're just a bunch of characters together, and they have the same name. They have different memory locations, but each one of them occupies the same amount as a character. So each one of these will occupy a byte. The only difference between the different parts of the character array are these little things called an index, and the index is where each of them is stored, and we can actually access those individually, but we'll talk about that a little bit later. So here's how we actually declare a character array. So I do char name, just like we would in any other declaration. The name has to be legal. It's got to start with a character or an underscore, and it could then have numbers or characters or an underscore in them as well. Then it's got these little square brackets. The square brackets tell us that it's a character array. So that means that over here in my memory space that I've got a bunch of them with the same name. And so what happens here is this is the first way we can declare and initialize. We do char name, open square bracket, close square bracket, is assign the value, and in double quotes I would put my values that I want. So in this case I want somebody in there. Well, what happens is those somebody, they go in here in my name1 memory location, and as you can see they're just S-O-M-E, B-O-D, and Y. They're all in single quotes because they are characters. And then this last little guy here in slot number 8, notice they are numbered in sequence from 0 through 8. So 0 through 8 gives us 9 characters. But that last character happens to be what this funky little thing. I have a \0, or I could have just put a 0 in there with no single quotes in there. But I like to put this \0 in there to designate that that is my null terminator. The null terminator just simply says that's the end of my string, and in reality what it does is when I print out a character array, I use %s, and the printf will actually go character by character by character until it hits the null terminator, or a 0 somewhere. If it doesn't have that guy in there, if it wasn't there, it would keep printing out characters until it finally got to a 0 in the memory locations. And that's not a good thing necessarily, but that is how it works. So the second way we have here is character name2 with the square brackets with a 9 inside of it. This tells the computer, the compiler, to save 9 locations, memory locations. Again, they're going to be numbered 0 through 8, and they're going to have whatever we tell it to put in there. In this particular case, I told it to just put me in the memory locations. What happens over here in my memory is I have 0 gets the M, 1 gets the E, and 2 now has the null terminator. So when I print it up, there are all these other guys, there's nothing in them. Actually, there's garbage in those other folks. And if we actually printed them out, it would show us garbage. The garbage actually kind of looks, usually in the ones I run at school, it kind of looks like that character there. It's kind of interesting that it shows up that way all the time, but that's the way we see them. Anyway, the last way, I'm just declaring them without initializing them. When I declare without initializing, I just do char name3 in this case, open square bracket 9, close square bracket, semicolon, and that just says save memory location for me. Don't put anything in them, but naturally there is something in them. It can't just be empty. Just like space, computers abhor a vacuum, so we don't, at least memory abhors a vacuum. So there's got to be something in there. In this case, it looks like there's nothing in there, but really there's garbage. And if you printed out the name 3, you'd find out that there is garbage in there indeed. Okay? Here is just outputting. Again, the null terminator tells me where to stop printing. I also can scan in character arrays, and if I want to use a scanf, I could do a %s. S stands for string, and these are not technically strings. If you hear somebody call them strings, you could ask them whether you want a character array or a string. But anyway, there's a %s, that's going to be for my string. And then I do a comma and name3. Notice there's no ampersand, and the reason there's no ampersand is because technically name3 is already a pointer, and the ampersand just tells the compiler when I do the scanf that look for the memory location associated with that guy. And we already know that that is a pointer to the memory location already, so we don't have to use the ampersand there. Now, normally after our scanf we have a flush all. Well, I'm not sure if it's the new standard for C++ or if it's the compiler that we're using, or whichever compilers. We've seen this in more than one compiler, but the flush all does not seem to be doing what it's supposed to. So we're going to not use the flush all when we do a scanf for a character array. Instead, we're going to use this guy. fseek, all lowercase, open parentheses, stdin, so for standing for standard in. That's our standard input device. And then a comma, then a 0, then a comma, and then all in caps, seek, S-E-E-K, underscore, end, E-N-D, close parentheses, semicolon. This guy here is going to flesh out our buffer, our keyboard input buffer, our input buffer, and it's just going to make sure that it's all gone and there's nothing left in there residual. And this is important not for the first time we scan in, but for the next time we scan in. Matter of fact, here's a little clue for people who want to get in more than just letters and numbers. If you want to get in tabs and spaces, those are called white space, or even a new line. In this particular case, we can do, if I have a character called input, character array called input, I have 256 characters in there, so it's a big character array. If I want to get spaces and tabs in there in this case, I could do scanf, double quote, %255, open square bracket, and a caret, which is a shift 6 on your keyboard, and a \n, close square bracket, double quote, comma, input, close parentheses, semicolon. What this does is it scans up to 255 characters, or until it gets to this new line. Now, the caret actually means don't get that character, and you could put anything in there, but right now, we're just seeking all the way up until we get there. Then, of course, we have this fseek and this same thing we had up here, and it's going to flush our buffer. Now, if I wanted to end on any character, I could put whatever character I wanted there. Problem that I have some of my students do at school, we actually end on a tilde. Now, the one thing about ending on a tilde, or whatever it happens to be, if you really do this scanf with the %255, or with one less, of course, than this input really is here, and the reason why is because of the null terminator. Then when I have a caret and the tilde, or a caret, whatever that character happens to be, really I have to do that character plus an enter key, and then it will input my data. Again, this fseek, it really is necessary for the one after that. The next scan we're going to do, in this case, if this fseek is necessary for this scanf, and then this fseek is necessary for the next scanf, and so forth and so on, to clear out the buffer. So, little introduction to character arrays. Again, they are very useful because we don't always have just single characters that we want to use. We actually have names maybe that we want to use, or we have other input that we want to use that is more than one character, all associated with the same name, the same variable name. So, character arrays, use them, again, in good health, and have fun programming C++, and hopefully see you back next time for more C++ with Miyoshi.